Okay, let's take a look at the next problem we have here. This problem is asking us to determine the values of the currents when the circuit is at steady state. Steady state, pretty useful term there. So what does steady state imply? Well, steady state means we are at time is equal to infinity. So we know that how certain elements are going to act during steady state. First, we see that here, this switch, which was initially open, is now going to flip down to closed. So it's like that. And it stays like this at time is equal to infinity, so it's closed. So this current goes here, through there, hits here, and breaks off like this. Okay? And there we go. All right. So we are not quite familiar with how to do certain charging discharging equations yet. So looking at this, the best thing in the world that you'll get for these problems is steady state. That is your best friend, because if we know how these elements act at steady state, we can do things with them. So if I let current run through this inductor forever, then the inductor will act just like a wire. And then if I run current through this capacitor forever, the capacitance will clip itself out. The reason for that being is that capacitance can only hold so much. So once it fills up, that's it. It can't take any more. So it'll essentially clip itself out of the circuit. So knowing this set of information, let's go and redraw the circuit. Okay. So this is our new circuit. So 5, 10, then 10. And we still have current 1, current 2, and this will be current 3. All right. And looking at this, it makes this problem a lot easier, right? Because now we just removed all the elements that we haven't really worked with before. So now we only have resistors and a battery, or this is 20 volts. And so we can just treat this like a regular problem that we've worked before. So we'll see that these are in parallel. And then after we combine those down, these will be in series. So R parallel will be 10 times 10 over 10 plus 10, which will give us 100 over 20, which will give us 5 ohms. Then R series 1 will give us 5 plus 5, which will give us 10 ohms, which is equal to R equivalent. So it'll just be this. 20 volts. All right. And now if we can find the current coming out of this battery, this will be I1. So all we need to do here is say I1 is equal to V over R equivalent, which will be 20 volts over 10 ohms, which gives us a total of 2 amps for I1. All right, so that's the first one. If we go look at the next equation, we need to figure out what I2 and I3 are. And if we know that 2 amps comes in this way, and it'll break off that way and break off that way, where no current will go down this branch or that branch, just pass through like that, then that's a clear current division. So we need to go ahead and do a current division on that. And luckily for us, we already found our parallel. So to find I2, that'll be R parallel over R10 times I1, which will give us 10 over, R parallel was 5. 5 over 10 times 2 amps. And therefore we will get 1 amp for I2. And then we can do the KCL where we just check it. So I1 goes in this way, I2 and I3 go that way. So I1 is equal to I2 plus I3. Therefore, I3 is equal to I1 minus I2, which will give us 1 amp. Or we can also do this. I3 is equal to R parallel over R10 times I1, which will give us the same results. All right. So just knowing that steady state and what the elements act like during steady state is super, super beneficial.